Arvind, is it 1.2.1? Sorry, 1.21?
1.21.
Okay, okay.
Let me tell you, I'll check it mine one, but it's a 1.21.
Okay,
Mm.
Arvind.
Okay. So Airflow is a orchestration tool. Okay, workflow scheduler tool. Okay, and Airflow is a Python-based DAG scheduler tool, orchestration tool. Okay. Okay. So we have other alternate in Hadoop, UG, but nowadays everywhere the Airflow is used because UG has a dependency on the Hadoop. Okay. So UG is the Hadoop ecosystem component. Okay, ecosystem component. So UG is the workflow scheduler of Hadoop, workflow scheduler, and UG has like two main component in UG. Okay, first is how many types of workflow in UG. So I'm just giving an idea, right? You can know, right, what is a UG. So UG is having a one is a simple workflow type, some simple workflow job. Okay, and second one is coordinator job. Okay. So simple workflow job. Second one is a coordinator job, and third one is a bundle job. Okay. So simple workflow job is basically it's a on-demand scheduling. On-demand scheduling, like whenever I want to trigger, I want to schedule a job, I want to trigger a job, I can trigger. Okay. Coordinator is a basically time-based and database or database dependency. Okay. So here in coordinator, there is a coordinator.xml file is there. The coordinator.xml file, it contains the the time frequency, right? The start date, right? Okay. So start date and start date, start time, okay, and time interval. Okay. So these all parameters we provide in the coordinator.xml. Okay. And if I say the simple workflow, the simple workflow is having a workflow.xml. Okay. So workflow.xml will be here also plus workflow.xml. But here one extra XML is there, that is a coordinator. Okay. So coordinator is basically providing the time dependency and data dependency related parameters. Okay. So UG needs one workflow.xml. This workflow.xml is contains actions. Okay. So actions are different types of actions. So it could be a hive action. It could be a scoop action, map reduce action, map reduce action. Okay. So whatever type of job you want to run, you will be define the action. Okay. Map reduce action, Java action, like if any Java job is there. So we can run multiple different types, Spark action. So Spark action, and the shell script is a bash. Okay. So bash is shell script. Okay. For shell script we use bash. Okay. Shell script. Like suppose you want to run a shell script you want to execute. And coordinator, we have the workflow.xml will there. So that is common to all three. Okay. But coordinator is completely time and data dependency. Okay. And bundle is we can say it's a combination of like workflow plus coordinator. Workflow plus coordinator. Okay. So here is bundle is some other different purpose. Okay. Where generally mostly we use either simple workflow or coordinator. Okay. And bundle, I'll have to check because bundle I'm not sure. But these are the two mostly used. And when we are defining this XML, right? So this workflow.xml, has action. So you will be defining one root tag. You will be defining one root tag workflow, and this workflow tag we have action. So I say this action is a hive action. So this is a type of hive. So you will be defining the, like you are running some script. So generally Hive is having the script, right? So we have test.html, like some script file is there. So this HTML file is the path of the script we are giving. Okay. Okay. So whatever type of job it is, it will be having that type of parameters you have to pass. Okay. And then close the Hive action. Suppose you have a scoop action. So scoop import file command you can give, or you can give the import script, right? You can give the shell script. So shell script you want to run. So shell is there, action type is a shell. And then you will give the batch script path. Okay, batch script path. So your script path will be coming in the tag. Okay. So here is a batch script you will be ending batch script, and then you will be ending the action. So like this sequential way you are doing. But suppose you want to run two actions parallelly, like two actions you want to run parallel, two actions run parallel. So we use the for. So for case like a way. So I want to do these two statement, do these two action. I want to run parallelly. So otherwise it is running a sequentially. Okay. But I want to run parallelly. So I will keep it these two action in the for. So I will start one for. So for tag is there for. And when I end it, when I keep it these two in the for, so action will automatically become parallel. Okay. So like this, it will become parallel. So that is the way. So how to start the UG job? So there is a UG job run command is there. UG job and hyphen run, and we have to give the UG UI is there. Okay. So localhost colon 11,004. So we have UG UI, and when we run the UG job, and we have to provide one minus property file also. So job.property is the property file. One property file is a job.property. So this job.property file contains job.properties, and then last is the command is run. Okay. So this job.property contains this job.property contains the resource manager URL, resource manager name node, okay, and workflow action, workflow dot XML application path. So where your workflow, so all those information are given. So when I give the job.property, it will pick your workflow.xml, and workflow.xml you have all these actions. And after this, you will get one workflow ID. So once your job start, you will get a workflow ID. This workflow ID is its workflow ID is starting either W or C. So W for the simple workflow and coordinator is C. So some like number will be there. And this number is a tracking number. So you can like get more information, right? Or UG job minus status. Then you can give the workflow ID. So this workflow ID you provide, and then it will give the state. So these are the command line, but UG has the user interface on this server and port, so we can. So in Ubuntu, UG is not easy to install. It takes more time and it is very complicated process. So either UG we can practice in the Cloudera VM, okay, or UG if you basically understand the concept, then it's good enough for interview point of view, because nobody is using UG nowadays in the. So UG you can check once with this tutorial point, UG tutorial point. Okay. So this tutorial is complete information about whatever I explained to you, like introduction to start the workflow. So this is examples of the workflow, like you have some script are there. And this script is a SQL script, right? This is a Hive script, right? Create table, ORC table, external table, right? And this is a workflow.xml. In the workflow.xml, this is an action. So when I'm using a Hive action, so I'm having a tag Hive. And this Hive tag is taking my script path. Okay, my job tracker ID, name node. Generally, these information we provide through the job.property. But if you don't want to use job.property, you can directly give this job tracker and name node. Directly, you can give in the workflow.xml in Hive action. So every action you are repeating same thing. So better to give through the job.property. So we can avoid this. We can avoid this and we can give only the script path. So this particular action is a Hive action, and every action having a one OK node and one error node. What is a OK node? OK node is like like a DAG. DAG you already know in Spark, right? It is a graph, right? Which is every node, every like vertex is connected to any other node, right? So same thing is here. Like here is the action is a one node and which is redirecting to the create ORC table. If create ORC table is called, it is connecting to you insert into table. Insert into table is connected to end. Okay. If any point you get the error, you will be sending where kill job. Everywhere your error is coming, you will kill the job. Because if error is coming means it is not successfully done. So might be your script is not a correct path, right? Your script is a wrong path. So it will fail. When it will fail, so you will redirect to error. You will redirect to error. You will redirect to error. And finally, error is just showing kill message. Like you are showing you are killing the job. The job will automatically kill, but you are showing the message job failed and you have ended your workflow. So in this workflow, these are all Hive scripts. So one is a create Hive external table, one is a create ORC table, and then you are inserting data into your table. Okay. So you are running this script. You are giving a .hive file, and this .hive file you have here in the same location. So these Hive file will be called, and two Hive files are creating a table, and one Hive file is inserting data from external table to ORC table. So it is like an insert query you are doing. Okay, you are selecting the data and then inserting data. So this is an example of, so how to run the UG job. I told like UG job and UG, and this is a local host 8. This is 8080 running, but 11,000 port is a default port. And then you give the run command, -run command. So if you are giving, because here is job.property is not giving, so you are directly giving the workflow.xml. Okay, with this parameter, UG workflow application.path you are giving. But suppose I want to give my resource manager, node manager, all these things, and name node I want to give to the job.property. So I will pass the job.properties, and job.property has the location about the workflow.xml, then it will trigger the workflow.xml. But in this case, because every properties they added this job tracker and name node, that is the reason they have not given the job.property. So they have skipped the job.property. Second thing is fork. The fork I told you, whenever you want to create a multiple actions, right? So I have defined in this the fork. So I'm saying here is a two actions I'm doing in the fork. One is a create external table, and one action is a, so this create external table and create ORC table you are creating parallelly, because both are independent to each other. Because if I say this external table has no dependency on the ORC and ORC doesn't have the dependency on external table. So both table you can create parallelly. So what I did, I created a fork, and fork inside the fork I created two actions. One action is So you can see this action is matching here. You see this action is matching here. This action is matching here. So, so simply pop you are using for running a two action parallelly, and other remaining things are the same. Okay. So sometimes we can use a decision making statement also. Like it's completely programming things they have made in the XML form. Like decision is like a if external table exists, this is like a condition. So if I say if this particular external table node is exists, then only you will be switching. So I'm saying if external table exists, then only create a table, create external table. Okay. So and otherwise, if it is not there, then it's a default to the ORC table. Okay. So two action are there. So based on this external table exists action, you are deciding either go to the create external table. Okay. So there is a case, right? If external table exists, so here you are checking create external table exists case, then you will be like you are checking if exists this path you are checking, because while creating a external table, you need some location path where you have to give a table location. So if you see here in the script /abc script, here is there, say test abc. If this location is not there, okay, so it is what is doing, right? Here is a true false things is there. So if exists, so you are checking here equal to false. So this case you call the create external table, and you are checking the file system path test abc if it is coming true or false, right? Okay. So you want to do in this particular case what you want to do, right? You are just going to check the condition. Okay. So this is a decision making some condition statement you can give. Okay. So if you want to use a property file, so they have given the option to the property file. So in property file, you can define the name node, job tracker, right? And some script path you can give, or workflow.xml path you can define here. So if you are using job.property, so job.property if you are using, so job.property, like you can dynamic parameterize properties, you can pass it here. Okay. And here you are giving a property file path. Okay. So if you are using property file path, you don't need to give, because if you are giving in property file your workflow.xml, so you don't need to give separately your workflow.xml. Okay. So workflow.xml you don't need to give. Only job.property is sufficient. Like this config job.property. So this workflow application path, it will be taken automatically from your job.property, because job.property is defining your workflow.xml path. Okay. So coordinator, I told you it's like a frequency based. So coordinator.xml is there. So these are the parameters, right? So these are the timeout, these are the properties like start time, end time. Okay, frequency is the 5 minutes. So every 5 minutes you want to schedule your job, so you can use this coordinator. But along with coordinator, you are using your this workflow.xml. Okay. So workflow.xml will be there, but same workflow it will run as a schedule interval time. At every 5 minute schedule interval time, it will keep running your workflow. Okay. So sometimes we are looking in some directory where some files are arriving, okay, from the source. Okay. But suppose the files are not coming immediately, right? So we are keep running the job, right? So sometimes our job is particular time, it is getting the data, but sometimes it is keep running every 5 minute, 10 minute, or 1 hour interval and keep checking the data. So if that kind of scenario is there, we go for coordinator. If you have to run a particular time, okay, right, I want to trigger. So even that also I can do coordinator. But simple workflow is like when you are triggering manually, like you want to trigger workflow manually, you can trigger by using a UG job run command. But here you don't need to trigger with the UG job run command. And there are many status are there. There are different status of the job. If your job is running status or pre-suspended, suspended status, there are the many status are there. Killed status, okay, failed status, like when your job is failed. Okay, so those are the different status. Okay, bundle is basically bunch of coordinators. So it's a combination of coordinator plus workflow. So suppose you have a different coordinators are there, okay, and you can create a combination of coordinator plus workflow. Okay, so coordinator is a combination of workflow plus the coordinator.xml, right? Okay, but bundle is a combination of coordinator plus workflow, right? You can create a multiple like bunch of coordinator, right? So I can define multiple coordinator.xml files and can trigger a different workflows. So that is basically the bundle. Okay. Okay, so this is all about the UG. Okay. Next, when we come to the Airflow, so Airflow I told about, this is the orchestration tool. Okay. So when we are working with the Airflow, so Airflow, first of all, we should know the Python knowledge because we are writing a DAG file, Python file, and that is a DAG file. So DAG file is basically define the different actions. So here we call it operators. In Airflow, we call it operators, basically defined by task. Okay, so different tasks will be there, and these tasks are representing some operator. Okay, so if I say hive task is there, so there is a hive operator is there, hive operator. If it is a shell script, so bash operator is there, shell task, bash operator. Okay, if we have a Spark is there, so Spark submit operator is there, Spark submit operator. Okay, but Spark job we can run with the bash also. So bash is common. So anything is in the shell script, anything is in shell script, we can run bash operator. So bash.
I have a question, Arvind.
Yeah.
I have a question. If we integrate the notebooks together, I mean, let's take an example. We can run one notebook to another notebook, right? I mean, inside the notebook, we can run Spark job. So what is the use of this workflow management? We can do that without.
There is a workflow itself is there. Okay, you don't need to use the Airflow in the Databricks. Now there is a their own workflow is there. So that workflow that can do, right. But if you want to still do, so there is a the Databricks submit operator is there. Okay, there is the operator.
Okay.
So you have to different operator you will create. Okay, like Databricks submit operator in Airflow. Suppose you have a 3 notebook. Okay, so what you will create, you will 3 tasks you will create. This is a Databricks submit run operator. Okay, so you will create a 3 different tasks and you will schedule T1, T2, T3. Correct. So this is like a one notebook, right? You have made a connection. So connection is one there is an option in the Airflow. You can create a connection, and that connection will be used to how to connect notebook, because notebook is somewhere in some host is there, and there is a Databricks is installed, right? So you have to give the complete connection parameters. So when you, that is the thing you are providing here, right? Cluster you are providing, right? So and you are telling about the
cluster configurations.
Yeah. So
It's
this
already inbuilt.
operator, suppose you have a multiple notebook and you want to trigger one after one another notebook like that you want to trigger, right? So once you create a task of your Databricks submit operator, same you will for all 4 or 5 classes are there, right? All these notebooks, right? And then you can have a dependency. You can define a dependency by using a greater operator. Suppose one task one greater than task 2. So it will be sequentially run, right? All this task, right? Task 1, task 2. So task 1 is completed, then task 2 will be run. So this way you can call the Databricks submit operator you can use. So like for even a lot of clouds operators are there, a lot of operators are there. So we have to decide which operator we want to use. So I'm talking about here like a simple basic operator, which is used for Hadoop ecosystem component like Hive, Scoop operator, like one Scoop operator is there. Okay, Spark operator. So Spark can be run by two ways. One is Spark submit operator is there. That is this one. So here is need a connection. Here is need a connection, right? So same like I'm talking about the Databricks, right? So Databricks is a separate configuration is there, right? The Databricks notebook. So we need a Databricks connection, and then we can run the Databricks notebook. Same like if you want to use a Spark submit operator, you have to connect connection. Like our Spark is running, right, locally, and connection with the Spark. Okay. So there is we have to create a connection. I will show that, and then we can trigger this Spark submit operator. Okay. So everything you will define in the DAG file. This is a DAG file, and DAG file we define in the Python file, right? In this DAG file, you will be defining the DAG variable. Okay. And then you defining the task, different tasks. You define task 1, and this will be some operator. Okay. Second one is the task 2. You define some operator. Okay. And these operator will be defined the dependency by using the greater getter operator. You can define the dependency. So that will be showing it like you have one task, two tasks. Suppose I say two tasks you have parallelly. So there is a square bracket you can use like, okay, suppose this task 1, task 2, and task 2, task 3 will be running parallelly. Okay. So here, like this operator, like this way we define. Okay. So we will understand like how this do. But I'm telling you, shell script is a very common, right? Because you know, scoop script, scoop import command, if I write in shell script, Hive command I can write in the shell script, right? I can call any Hive queries, I can call from the shell script, right? Or Spark submit job, I can call from the shell script. So shell script is a common which can trigger any type of job. So one way is separate operator is there, separate job, right? Hive is there, Scoop is there, Spark is there. But if you want to call a commonly as a shell script, so shell script is having bash operator. So bash operator is there. So first we understand what are the component of Airflow. Okay, like what Airflow has. Okay, so Airflow we will talking about the DAG, right? So DAG is a direct acyclic graph. So we create a one DAG variable, and this DAG variable, and basically DAG is nothing but one DAG ID is there, and this DAG ID is in our UI. When we install the Airflow, you will see this DAG ID will be available in the UI. We will recognize this DAG ID. So whatever name you give in the DAG ID, and that DAG ID will be recognized the DAG. So DAG is a collection of tasks. DAG is collection of the tasks. So if you see, there are the different tasks are there, like 3 tasks. These are 3 tasks running parallelly. These 3 tasks, 2 tasks are running parallelly, and this one task. Okay, so this is the order. Order is like here, this all 3 completed, then like this task order is there. Okay, so this is a complete UI. I will show you that when the DAG is running, you can see the loggings, everything you can see. So there are the different operator are there, bash operator, Python operator, email operator. Like suppose you want to HTTP request, you want to do some REST APIs. Suppose you want to get the data from the SQL, Postgres, MS SQL. Okay. So there are the different operators are there. AWS cloud operators are there. Azure is there. GCP there. So different. Some sensor operator are there. Sensor operator is checking whether the file is arrived or not. So if you have some S3 AWS path, you are keep checking your file is arrived or not by S3 key sensor is there. Okay. So there are the different sensor means where something you want to check whether it's exists or not. Okay. Then you want to perform some action. So sensor operator is there. Okay. Another concepts like a hook is there, XCOM is there. Suppose one DAG to another DAG you want to communicate, like you want to pass the input data, right? Some data you want to pass from one DAG to another DAG. I'm talking about the DAG here. Okay, so one DAG to another DAG, XCOM is there. Okay, so task instance, these are all part of the DAG. Okay, and XCOM is like basically when we are linking the DAG. So when we want to connect one DAG to another DAG, okay. And this dependency, two ways you can show. One is either you can call the function like set downstream and set upstream, or you can do greater or operator like this. So you can use a greater or less operator you can use, or you can use like a function downstream. So mostly this is a more convenient way. So here it is very clear, like task 1 is completed and task 2. So same thing you can do like this. So task 2 is dependent on the task 1. Okay. So like this, like task 2 is not starting when the task 1 is not completed. Okay. So like this, you can define the dependency. So this is the easy way to define the dependency. Okay. And you will see this type of color coding. Okay. Success, running, failed. Okay. So it is easily, you can recognize your job is what is the current status. It is a failed, it is a running, it is a, so all are different colors. We can easily check, right? If yellow color is there, so what is the status? Okay. So Q status or no status, or if green is there, dark green success and light green is a run. Okay. So total 4 component is there in the Airflow, in Airflow architecture. One is Airflow scheduler, Airflow web server, Airflow executor, and Airflow metadata database. Okay. So metadata database is containing the data about the jobs, like it's just the metadata information. Executor is the whatever the operator we are saying, the executor is executing the actual task, Okay. So there are again executors are different types of executor. Sequential executor. So sequential executor is a sequentially it is running the task. Okay. Another one is a Celery executor. Celery is mostly used in the distributed environment, right? Distributed where multi-node cluster is there. So we use the Celery. Okay. So Celery is for the distributed, and other one is Kubernetes container based. The Kubernetes is there. That is for containers. This is for container. Okay. So we mostly use sequential, but if we are doing the deployment in the prod or some higher environment, so we go for distributed. Okay, Celery. Okay, so just we have to change the executor type. So there is a config file of Airflow CFG file is there. So Airflow CFG file. So there you can change the port and everything. You can change that. The scheduler is basically scheduling a job. So whenever you are using the scheduling option, when you are using a scheduling option in your DAG file, scheduler will come in picture and schedule. But scheduler and server, these two, we have to start. Okay. So Airflow scheduler is a command to start the scheduler, Airflow scheduler. Okay. And for web server, Airflow server, web server. So this command web server is for UI, Airflow UI. So whatever UI you are able to see, so that UI is coming because of the web server. So it's a web application basically. It's a web application, and web server is started by using the Airflow web server, and we have to tell the port 8080 or whatever, if it is a different port. Okay. So we have to use this. But whatever installation we do, so there is a command Airflow standalone command, and that command itself start both. You know, right, in the Hadoop is a start -all.sh. So same is Airflow standalone command. Okay. So this command as itself start the scheduler plus web server. Okay. Okay. So how to installation we do? Okay, because installation is we are doing manual installation first. We are installing in the Ubuntu. So So installation, okay, we will not be covered today, but you can follow this one, except the Python you don't need to install again, okay, except this statement, right? Okay, JDK, because if you have already Java, right? So these two statements you don't do this one, or JDK statement and Python statement don't do, but everything else you do. Okay, and here you this one 3.8 report. But this mean also you can leave it. So let me I modify it so you can. It's a very straightforward. Okay, so you can install the doing the installation. So sudo apt update you start, or this one, and this is commented, so leave this one. And JDK, this is already you have, so you don't need to run because it's not to start JDK. And Python also, if you have to check it, otherwise it will install the Python. Okay, so run this statement, and this one here we have different provider. Okay, so all the provider is not used. Okay, so I'm just removing it. Just use SSH and MySQL. Okay, Oracle and these other provider for time being you don't use it. Okay, Spark you can do. Okay, Spark you can do. So this provider you install. Okay, other provider I will tell, and then you start this Airflow standalone, and then you will get the one admin and password. Then open your HTTP localhost 8080. Okay, and then you will get admin will come. Or try it, like it will, after this it will ask the username password, so enter. So your password will come different. Okay, when you run this last command, right, once you are done, right, you will see it will show you when you start this standalone command, so it will show you the username and password, and that what password will remain forever the same password. Okay, but your password will come different. Okay, so you will see whatever password comes, use that username password, okay, with this URL. So you will see your Airflow homepage you will get. Okay. So just try this out. Okay. I believe this all statement you have to run and try with the Airflow standalone command. This is a command to start your Airflow. And once you start the Airflow, you will get username password. Okay. Okay. I will paste it this all. Okay. Let me. Or you can use in my this classroom link, and then you can check. Let me give you here. You can. Okay, so here everything is there. Okay, this document. Okay, so you can take it. Okay, and you. Okay, so tomorrow I will show you the demo on that. Okay, Airflow will different examples. Okay, thank you.